Running instrument air into an explosion-proof enclosure is a fairly common practice. The crucial aspect involves ensuring that the bulkhead fittings are installed by a competent person and are properly certified for use in hazardous areas. The bulkhead fittings themselves must carry explosion-proof certification, and they must be meticulously sealed to the enclosure to maintain its integrity. Firstly, the air lines must be properly sized to meet the demands of the specific application. Insufficiently sized lines can lead to operational issues, while excessively large lines may introduce unnecessary complexities. Secondly, it is highly recommended to engage a qualified electrician to handle the installation of the bulkhead fittings and the subsequent connection of the air lines. Their expertise ensures adherence to safety standards and proper sealing techniques. Thirdly, after the installation is complete, it is imperative to have it inspected by a qualified inspector. This inspection verifies that the installation is indeed safe and fully compliant with all applicable codes and regulations, providing an additional layer of assurance. Explosion-proof enclosures are designed to contain an internal explosion without causing an external hazard. They are used in locations where flammable gases, vapors, or dust may be present in the air. These locations are classified as hazardous locations, and they require special electrical equipment that is designed to prevent ignition of the hazardous materials. The National Electrical Code (NEC) provides detailed requirements for explosion-proof enclosures. These requirements cover the design, construction, installation, and maintenance of explosion-proof enclosures. Some key NEC requirements for explosion-proof enclosures include: firstly, the enclosure must be strong enough to withstand an internal explosion. Secondly, the enclosure must have flame paths that are long and narrow enough to cool the escaping gases and prevent them from igniting the surrounding atmosphere. Thirdly, the enclosure must be properly sealed to prevent the entry of flammable materials. Fourthly, the enclosure must be properly grounded to prevent the buildup of static electricity. Explosion-proof enclosures are typically made of metal, such as aluminum or steel. The enclosure is designed to contain an internal explosion without causing an external hazard. The enclosure has flame paths that are long and narrow enough to cool the escaping gases and prevent them from igniting the surrounding atmosphere. The enclosure is also properly sealed to prevent the entry of flammable materials. The bulkhead fittings are used to connect the air lines to the explosion-proof enclosure. The bulkhead fittings must be certified as explosion-proof. The bulkhead fittings must be properly sealed to the enclosure to prevent the escape of flammable materials. The air lines must be properly sized for the application. The air lines must be made of a material that is compatible with the hazardous materials that may be present in the atmosphere. The installation of explosion-proof enclosures and bulkhead fittings is a complex task that should only be performed by qualified personnel. It is important to follow all applicable codes and regulations to ensure a safe and compliant installation. The selection of appropriate explosion-proof enclosures and fittings is crucial for ensuring safety in hazardous locations. Several factors should be considered, including the specific hazardous material present, the area classification, and the operating temperature. The NEC classifies hazardous locations based on the type of hazardous material present and the probability of its presence in the air. These classifications include Class I, Class Roman II, and Class Roman III locations. Class I locations are those where flammable gases or vapors may be present in the air. Class Roman II locations are those where combustible dust may be present in the air. Class Roman III locations are those where ignitable fibers or flyings may be present in the air. Within each class, there are divisions that further define the likelihood of the hazardous material being present in the air. Division 1 locations are those where the hazardous material is likely to be present under normal operating conditions. Division 2 locations are those where the hazardous material is not likely to be present under normal operating conditions, but may be present under abnormal conditions. The area classification is used to determine the type of explosion-proof equipment that is required. Explosion-proof equipment is designed to contain an internal explosion without causing an external hazard. The equipment is also designed to prevent the ignition of flammable materials in the surrounding atmosphere. The operating temperature of the equipment is also an important consideration. The equipment must be designed to operate safely at the maximum temperature that it is likely to be exposed to. The NEC provides detailed requirements for the installation of explosion-proof equipment. These requirements cover the design, construction, installation, and maintenance of explosion-proof equipment. Some key NEC requirements for explosion-proof equipment include: firstly, the equipment must be properly grounded to prevent the buildup of static electricity. Secondly, the equipment must be properly sealed to prevent the entry of flammable materials. Thirdly, the equipment must be installed in accordance with the manufacturer's instructions. Fourthly, the equipment must be inspected and maintained on a regular basis. The selection and installation of explosion-proof equipment is a complex task that should only be performed by qualified personnel. It is important to follow all applicable codes and regulations to ensure a safe and compliant installation. Bulkhead fittings are essential components when routing air lines or other fluids into explosion-proof enclosures. They provide a secure and sealed connection point that maintains the integrity of the enclosure and prevents the escape of any hazardous materials. When selecting bulkhead fittings for explosion-proof applications, several factors must be considered. Firstly, the fitting must be certified as explosion-proof. This certification ensures that the fitting has been tested and meets the requirements for use in hazardous locations. Secondly, the fitting must be compatible with the type of fluid being routed. Different fluids may require different materials and sealing methods. Thirdly, the fitting must be properly sized for the air line or other fluid line being used. An undersized fitting can restrict flow, while an oversized fitting can be difficult to seal properly. Fourthly, the fitting must be properly installed to ensure a secure and sealed connection. This typically involves using a torque wrench to tighten the fitting to the manufacturer's specifications. In addition to these factors, it is also important to consider the environmental conditions in which the fitting will be used. For example, if the fitting will be exposed to corrosive materials, it should be made of a corrosion-resistant material. If the fitting will be exposed to extreme temperatures, it should be made of a material that can withstand those temperatures. The NEC provides detailed requirements for the installation of bulkhead fittings in explosion-proof enclosures. These requirements cover the design, construction, installation, and maintenance of bulkhead fittings. Some key NEC requirements for bulkhead fittings include: firstly, the fitting must be properly grounded to prevent the buildup of static electricity. Secondly, the fitting must be properly sealed to prevent the entry of flammable materials. Thirdly, the fitting must be installed in accordance with the manufacturer's instructions. Fourthly, the fitting must be inspected and maintained on a regular basis. The selection and installation of bulkhead fittings is a complex task that should only be performed by qualified personnel. It is important to follow all applicable codes and regulations to ensure a safe and compliant installation. Proper sealing techniques are critical for maintaining the integrity of explosion-proof enclosures. The purpose of these enclosures is to contain any internal explosion without allowing it to propagate to the surrounding environment. Therefore, any openings or penetrations in the enclosure must be effectively sealed to prevent the escape of flammable gases, vapors, or dusts. Several methods can be used to seal explosion-proof enclosures, including: firstly, threaded joints. Threaded joints are a common method of sealing enclosures. The threads must be clean and free of damage. A thread sealant or tape should be used to ensure a tight seal. Secondly, gaskets. Gaskets are used to seal mating surfaces between enclosure components. The gasket material must be compatible with the hazardous materials that may be present. The gasket must be properly sized and installed to ensure a tight seal. Thirdly, sealing fittings. Sealing fittings are used to seal conduit and cable entries into the enclosure. The sealing fitting must be filled with a sealing compound that is approved for use in hazardous locations. The sealing compound must be properly installed to ensure a tight seal. Fourthly, compound-filled boxes. Compound-filled boxes are used to seal electrical connections within the enclosure. The box is filled with a sealing compound that is approved for use in hazardous locations. The sealing compound must be properly installed to ensure a tight seal. The NEC provides detailed requirements for sealing explosion-proof enclosures. These requirements cover the types of sealing methods that are permitted, the materials that can be used, and the installation procedures that must be followed. Some key NEC requirements for sealing explosion-proof enclosures include: firstly, all openings and penetrations in the enclosure must be sealed. Secondly, the sealing method must be approved for use in hazardous locations. Thirdly, the sealing materials must be compatible with the hazardous materials that may be present. Fourthly, the sealing must be properly installed to ensure a tight seal. The installation of seals in explosion-proof enclosures is a complex task that should only be performed by qualified personnel. It is important to follow all applicable codes and regulations to ensure a safe and compliant installation. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of explosion-proof enclosures. Over time, seals can degrade, components can corrode, and connections can loosen. These factors can compromise the integrity of the enclosure and increase the risk of an explosion. Regular inspections can help to identify potential problems before they become serious. During an inspection, the enclosure should be visually inspected for any signs of damage such as cracks, dents, or corrosion. The seal should be inspected for any signs of deterioration such as cracks, hardening, or loss of elasticity. The connections should be checked to ensure that they are tight and secure. The enclosure should also be tested to ensure that it is still explosion-proof. This can be done using a pressure test or a flame test. Maintenance should be performed on a regular basis to prevent problems from developing. This may include replacing seals, tightening connections, and cleaning the enclosure. The frequency of inspections and maintenance will depend on the environment in which the enclosure is located. Enclosures in harsh environments will require more frequent attention than enclosures in mild environments. The NEC provides detailed requirements for the inspection and maintenance of explosion-proof enclosures. These requirements cover the frequency of inspections, the types of inspections that should be performed, and the maintenance procedures that should be followed. Some key NEC requirements for the inspection and maintenance of explosion-proof enclosures include: firstly, enclosures must be inspected on a regular basis. Secondly, inspections must be performed by qualified personnel. Thirdly, maintenance must be performed to correct any problems that are identified during inspections. Fourthly, records must be kept of all inspections and maintenance. The inspection and maintenance of explosion-proof enclosures is a critical task that should not be neglected. Regular inspections and maintenance can help to ensure the continued safety and reliability of these enclosures. Compliance with applicable codes and regulations is paramount when working with explosion-proof equipment. The NEC is the primary code that governs the installation and maintenance of electrical equipment in hazardous locations. However, other codes and regulations may also apply, depending on the specific location and application. It is important to be familiar with all of the applicable codes and regulations before beginning any work on explosion-proof equipment. The NEC provides detailed requirements for the design, construction, installation, and maintenance of explosion-proof equipment. These requirements are designed to prevent explosions and ensure the safety of personnel and property. Some key NEC requirements for explosion-proof equipment include: firstly, the equipment must be certified for use in hazardous locations. Secondly, the equipment must be installed in accordance with the manufacturer's instructions. Thirdly, the equipment must be properly grounded to prevent the buildup of static electricity. Fourthly, the equipment must be properly sealed to prevent the entry of flammable materials. Fifthly, the equipment must be inspected and maintained on a regular basis. In addition to the NEC, other codes and regulations may also apply. For example, some states and municipalities have their own electrical codes that are based on the NEC. Other regulations may apply to specific types of equipment or installations. It is important to consult with a qualified electrician or engineer to ensure that all applicable codes and regulations are being followed. Compliance with applicable codes and regulations is essential for ensuring the safety of personnel and property in hazardous locations. Failure to comply with these codes and regulations can result in serious consequences, including explosions, fires, and injuries. When dealing with hazardous locations and explosion-proof enclosures, understanding the different classes, divisions, and zones is crucial for selecting the correct equipment and ensuring safety. These classifications define the type and likelihood of flammable materials being present, guiding the appropriate level of protection needed. Classes define the general nature of the hazardous material. Class I refers to flammable gases or vapors, Class Roman II to combustible dusts, and Class Roman III to ignitable fibers or flyings. Divisions further categorize the probability of the hazardous material being present under normal or abnormal operating conditions. Division 1 indicates a high probability of the hazardous material being present, while Division 2 indicates a lower probability, typically only under abnormal conditions. Zones, used in the European E6 system and increasingly adopted in North America, provide a more granular classification based on the frequency and duration of the presence of flammable materials. Zone 0 indicates a continuous presence, Zone 1 indicates an intermittent presence, and Zone 2 indicates a rare presence. Understanding these classifications is essential for selecting the appropriate explosion-proof equipment, including enclosures, fittings, and wiring methods. The equipment must be designed and certified for the specific class, division, or zone in which it will be used. For example, equipment used in a Class I, Division 1 location must be more robust and have a higher level of protection than equipment used in a Class I, Division 2 location. Incorrectly classifying a hazardous location or selecting the wrong equipment can have serious consequences, including explosions, fires, and injuries. Therefore, it is essential to consult with a qualified professional to ensure that the location is properly classified and that the correct equipment is selected. Proper grounding and bonding techniques are critical for ensuring the safety of electrical equipment in hazardous locations. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing a dangerous buildup of voltage. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. In hazardous locations, proper grounding and bonding are even more important because they can help to prevent explosions. Static electricity can build up on equipment and personnel in hazardous locations, and this static electricity can ignite flammable materials. Proper grounding and bonding can help to dissipate static electricity and prevent it from causing an explosion. The NEC provides detailed requirements for grounding and bonding in hazardous locations. These requirements cover the size and type of grounding and bonding conductors, the methods of connecting grounding and bonding conductors, and the testing of grounding and bonding systems. Some key NEC requirements for grounding and bonding in hazardous locations include: firstly, all metal parts of the electrical system must be bonded together. Secondly, the grounding conductor must be sized according to the size of the circuit conductors. Thirdly, the grounding conductor must be connected to a grounding electrode system. Fourthly, the grounding system must be tested to ensure that it is effective. Proper grounding and bonding techniques are essential for ensuring the safety of electrical equipment in hazardous locations. Failure to properly ground and bond equipment can result in serious consequences, including explosions, fires, and injuries. Surge protection devices, SPDs, are used to protect electrical equipment from voltage surges or transients. These surges can be caused by lightning strikes, power switching, or other electrical disturbances. In hazardous locations, SPD are even more important because they can help to prevent explosions. Voltage surges can damage electrical equipment and create sparks that can ignite flammable materials. SPD can help to protect equipment from damage and prevent sparks from occurring. The NEC provides detailed requirements for the installation of SPD in hazardous locations. These requirements cover the type of SPD that is required, the location of the SPD, and the wiring of the SPD. Some key NEC requirements for the installation of SPD in hazardous locations include: firstly, the SPD must be listed for use in hazardous locations. Secondly, the SPD must be installed as close as possible to the equipment that it is protecting. Thirdly, the SPD must be wired in accordance with the manufacturer's instructions. Fourthly, the SPD must be grounded properly. Surge protection devices are an important part of a comprehensive electrical safety plan for hazardous locations. Proper installation and maintenance of SPD can help to protect equipment from damage and prevent explosions. Intrinsically safe circuits are a technique used in hazardous locations to limit the energy available in electrical circuits to a level that is below the ignition energy of the flammable materials present. This is achieved by limiting the voltage and current in the circuit to very low levels. Intrinsically safe circuits are used in a variety of applications, including instrumentation, control systems, and communication systems. They are particularly useful in areas where it is difficult or impossible to use other methods of explosion protection, such as explosion-proof enclosures. The NEC provides detailed requirements for the design, installation, and maintenance of intrinsically safe circuits. These requirements cover the types of components that can be used in intrinsically safe circuits, the methods of wiring intrinsically safe circuits, and the testing of intrinsically safe circuits. Some key NEC requirements for intrinsically safe circuits include: firstly, all components used in intrinsically safe circuits must be certified as intrinsically safe. Secondly, intrinsically safe circuits must be wired separately from other circuits. Thirdly, intrinsically safe circuits must be grounded properly. Fourthly, intrinsically safe circuits must be tested to ensure that they are safe. Intrinsically safe circuits are a complex topic, and it is important to consult with a qualified professional before designing, installing, or maintaining intrinsically safe circuits. Proper design, installation, and maintenance of intrinsically safe circuits can help to prevent explosions and ensure the safety of personnel and property in hazardous locations. Fiber optic cabling offers several advantages over traditional copper cabling in hazardous locations. Firstly, fiber optic cable is immune to electromagnetic interference (EMI). This is important in hazardous locations where there may be high levels of EMI from electrical equipment. EMI can interfere with the signals on copper cables, causing them to malfunction or fail. Secondly, fiber optic cable is non-conductive. This is important in hazardous locations where there is a risk of explosion. A spark from a copper cable can ignite flammable materials, but fiber optic cable cannot produce a spark. Thirdly, fiber optic cable can transmit data over long distances without signal degradation. This is important in hazardous locations where equipment may be located far apart. The NEC provides detailed requirements for the installation of fiber optic cabling in hazardous locations. These requirements cover the type of fiber optic cable that is required, the location of the fiber optic cable, and the grounding of the fiber optic cable. Some key NEC requirements for the installation of fiber optic cabling in hazardous locations include: firstly, the fiber optic cable must be listed for use in hazardous locations. Secondly, the fiber optic cable must be installed in a conduit or other protective enclosure. Thirdly, the fiber optic cable must be grounded properly. Fiber optic cabling is a safe and reliable way to transmit data in hazardous locations. Proper installation and maintenance of fiber optic cabling can help to prevent explosions and ensure the safety of personnel and property. Wireless communication technologies are becoming increasingly popular in hazardous locations. Wireless communication offers several advantages over traditional wired communication, including: firstly, increased flexibility. Wireless devices can be easily moved and reconfigured. Secondly, reduced installation costs. Wireless communication eliminates the need to run wires, which can be expensive and time-consuming. Thirdly, improved safety. Wireless communication can reduce the risk of electrical shock and explosions. However, wireless communication also poses some challenges in hazardous locations. One challenge is the risk of interference from other wireless devices. Another challenge is the need to ensure that wireless devices are intrinsically safe or explosion-proof. The NEC provides detailed requirements for the use of wireless communication technologies in hazardous locations. These requirements cover the type of wireless devices that are permitted, the location of wireless devices, and the installation of wireless devices. Some key NEC requirements for the use of wireless communication technologies in hazardous locations include: firstly, wireless devices must be listed for use at hazardous locations. Secondly, wireless devices must be installed in accordance with the manufacturer's instructions. Thirdly, wireless devices must be protected from interference from other wireless devices. Wireless communication technologies can be a valuable tool in hazardous locations. However, it is important to carefully consider the challenges and to follow all applicable codes and regulations to ensure safety.